Okay, so we're going to continue with just one more example from section 4.1. Mainly we're just going to do an example of an application of angles. There was one piece that I'm not covering here in the videos. I'm not covering the conversions between degree measure and angles to radians or radians to degrees. Make sure you read about that in the textbook. I do find that it's for the most part pretty straightforward. So we'll just do a one example. Trying to find your speed along a circle. You're trying to find your speed along a circle, given some information about the numbers of revolutions per unit time. Okay, so what we're going to do is we're going to find your. So imagine you're riding a Ferris wheel. We're going to find your speed in miles per hour on a 100-foot tall Ferris wheel that makes one revolution every 5 minutes. Okay, so first let's maybe draw ourselves a little picture here. So here's maybe my Ferris wheel. Since the Ferris wheel is, actually let's draw that on the other side. Okay, since the Ferris wheel is 100 feet tall, that's going to tell me that the radius of the Ferris wheel is 50 feet. Okay, and we're going to have to use that radius eventually. Okay. Okay, so again, here's a picture of this Ferris wheel. Again, it's going to, as you ride on the Ferris wheel, you're going to be tracing out a circle of radius 50. Again, the Ferris wheel is 100 feet tall. So first, what you need to do is you need to figure out, before you can even figure out, the speed in miles per hour, we were given that there's one revolution every 5 minutes. Okay, so usually this is really a three-step process. Number one is just finding the number of revolutions per minute, and that's going to give you the fraction of a rotation created as you're riding the Ferris wheel every minute. So again, you're doing one revolution. You can divide that by 5 minutes, which is going to give you 1/5 revolutions per minute. Oops. And we can just write that as 0.2 revolutions per minute if we write that in decimal form. Okay, so you're making a 0.2 rotation every minute. Okay, and then the second step in this process is going to be finding the radian measure that you rotate every minute, and then we will use that to find the distance traveled along the Ferris wheel, or the circle that it creates, every minute. Once we do that, we can convert that rate, the amount of feet traveled per minute, we can convert that to the amount of miles traveled for every hour, and that'll give us our speed. Okay, so remember, the angle theta in radians is always the fraction of the rotation times 2 pi, and that would say that we're taking 0.2 revolutions per minute and multiplying that by 2 pi, and what we get here is we get 0.4 pi, and we're rotating by that many radians every minute. Okay, so on a new slide here, new page, we just calculated that the angle in radians that is formed every minute is 0.4 pi. Okay, now, if you want to find the distance the Ferris wheel travels circularly every minute, you're going to use the arc length formula. S equals the radius of the circle times the angle theta, and I guess I'll include the angle radians. Now remember, the Ferris wheel is 100 feet tall, making the radius 50 feet. You're going to multiply that by the 0.4 pi radians per minute, and this ends up equaling, give me a moment for my calculator, I'll just multiply the 50 by the 0.4, leave my answer in terms of pi. And what ends up happening is you travel 20 pi feet per minute. Okay, now that's going to be the speed that you're traveling along the Ferris wheel. Okay, so that's the distance you're traveling every minute in feet. Okay, so again, it's kind of a three-step process. You need to find the number of revolutions you make per minute. Use that to find the angle of rotation every minute, and then use your arc length formula to find the distance traveled around the Ferris wheel per minute. And then since the question wanted your speed in miles per hour, we have to convert this 20 pi feet per minute into miles per hour. So this is another example of unit conversions. Okay, so again, the speed is 20 pi feet per minute. Okay, so we're going to start here, 20 pi feet every 1 minute. And we need to eliminate the units of feet and arrive at the units of miles. Okay, so first let's do that, and then we'll convert the minutes to hours. Okay, so for the conversion ratio, you're going to need to be left with miles in the numerator, and you're going to have to multiply by the equivalent of feet in the denominator. And we know that in every 1 mile there is 5,280 feet. Okay, the units of feet will cancel, and you get 20 pi over 5,280, and the units are now miles per minute. Okay, now we're going to take that same quantity. We have 20 pi miles traversed every 5,280 minutes. And then we need a conversion now where we're trying to eliminate minutes in the denominator. So we need units of minutes in the numerator, and we want to be left with units of hours in the denominator. And we know that in every 1 hour there's 60 minutes. Okay. And the speed then in miles per hour is going to be, well, in the numerator I'll multiply 60 times 20. Again, we're going to leave our answer in terms of pi. That gives me 1200 pi over, and again, cancel out your minutes, 5,280, and that's going to be in terms of miles per hour. And just for an approximation here, I'll do my 1200 pi divided by 5,280, and I get approximately 0.72 miles per hour. Okay, so if you're on a Ferris wheel that's 100 feet tall, and you make 1 revolution every 5 minutes, if you're riding the Ferris wheel, you're traveling along a circle at 0.72 miles per hour. Okay, so like I said, a lot of these applications are similar. You first find the number of rotations or revolutions per unit time. Then you find the, using your formula involving the fraction of a rotation, you then find the angle in radians that you rotate by every unit time, and then you use your arc length formula to find the distance traveled every unit of time, and that gives you your speed. You might have to, at the end, then convert your units on speed to, so ours was originally feet per minute, and we had to convert that to miles per hour. Okay, so all the problems on the homework should be somewhat similar to that. Again, I didn't do radian to degree and degree to radian conversions, so make sure you look at that. More videos for other sections will come soon, and thank you for tuning in. Have a good one.